Welcome to sublesson 8.2, Configure TCP IP. In this sublesson, we'll jump straight into some demonstrations of how to configure TCP IP on the Linux command line. We are now logged into the CentOS box as the user vagrant. We want to examine the current network configuration, and we'll make some adjustments to make sure that TCP IP is set up correctly. First, we'll take a look at dmessage. We learned about this when we covered logging in the syslog lesson. What I want to show here is I'm going to search for the string ETH0. In order to do that with less, I press a / and I type ETH0. I press enter and it finds occurrences in the output of dmessage. And the reason for this is that ETH0 is our first network interface. By default, this is the name of the network interface on many Linux systems. This is just showing us that E1000 is the driver for our network interface. It shows that it's a 1 gigabit network connection. It's an Intel chip. So when we see this message, we know that Linux has recognized our network driver. In most cases, this just happens by default, and you don't have to make any changes. The next thing to look at is the PCI bus. We can use LSPCI to examine the PCI bus. This shows us anything attached, any adapter, any hardware attached to our PCI bus. And what we're looking for here is our Ethernet controller. This is our network card. We can see just a different view of the same thing we saw in the dmessage output. We can see the very specific device that our network card is, 82540EM. It's a gigabit Ethernet controller. Just further confirmation that Linux has seen our network device, so it knows it's attached to the system. Now we can examine the card at a layer 2 level. So thinking back to our knowledge of the OSI network stack, we're looking at layer 2 here. And we can see information about our network card. So there's all sorts of information specific to this card. It shows, for instance, that it's set to auto-negotiate, meaning that it negotiates its rate of exchange with the upstream network switch that it's attached to automatically. We don't have to set it to a gigabit. It tells the switch that it's capable of a gigabit, and if the switch is also capable, then they begin communications at a gigabit. It shows us that it's set to be at full duplex, the type of port that it uses. Importantly, here at the bottom, it shows link detected yes. So this means that the machine believes it has a network connection. It senses a cable plugged in and a connection on the remote end. If you were looking at the back of a computer and the network cable was plugged in, you would see a green light. That would indicate that the link was connected as well. This is Linux's confirmation that it also sees the link. So now let's examine the commands to explore and configure the TCP IP stack. One command is the IP command. This is really a suite of tools that lets you configure the network. IP adder shows information about addressing. And if we say show, we can see that. First thing to notice is that there are actually 2 links configured on my Vagrant box at the moment. There's the link LO, which stands for, this means loopback. Every system has a loopback interface. This is just a local interface that processes can use to communicate with each other via TCP IP, but never leaving the host. So imagine if you had a network card and you plugged a cable into it and then you plugged the other end of the cable right back into the computer. So it never actually went over the network. That's sort of what a loopback interface is. The loopback interface is configured with the IP address 127.0.0.1. Anything in the 127 range will always be loopback. And by convention, 0.0.1 is the loopback interface. So you'll see this on any Linux system you encounter. Next, we see ETH0. This is our primary network interface that's actually attached to the network. We can see that it's been assigned the IP address 10.0.2.15, and that it's configured on a network that is a /24 network, a Class C network. This is very common. We can see its broadcast address. We can see its MAC address, which is its layer 2 Ethernet address. We can show here, importantly, that it's up, meaning it's up and ready to communicate on the network. So this is the most basic way to view information about our network. This is also a brand new tool, or I shouldn't say brand new tool, but it is the replacement tool for the historical tool known as ifconfig, which is still present on almost every Linux distribution. However, it is now deprecated in favor of the IP route suite of tools that we just used. In any case, if you type ifconfig, you'll see many of the same details. You can see that it's an Ethernet attachment to the network as opposed to, say, a fiber attachment. You can see its IP address is 10.0.2.15. You can see its broadcast. Notice that rather than the CIDR notation that we saw here with the /24, we actually see a network mask notation used under ifconfig output. Just a subtle difference in how it's displayed. Ifconfig is also showing us some statistics. This particular display is showing us that we've received 395 packets and we've sent 249, so not a very busy card at the moment. It shows us the same information in bytes. It shows us error information. Sometimes if you look at this output, you might see errors or dropped packets. That almost always indicates some problem either with the cabling or upstream on the network. In any case, it's an error condition. These numbers should always be at or near 0. And we also see our loopback interface, just as we did in the IP adder show output. Linux can also be configured to show multiple IP addresses on a single interface. If you're wondering why that's useful, one example is for SSL. SSL, if you set up say an HTTPS website, must have a certificate tied to a specific IP address. Sometimes you wish to host more than a single SSL site on one host. And if you need to do that, sometimes you can just add a second IP address to the same interface. It can communicate with the network via all of those IP addresses, but you could host an SSL certificate for each subinterface. So let's show how to do that now. We can type sudo, we need to run this as root, IP adder add, and then we need to give it the IP address, and I'll pick one in the 192.168 range as one of our RFC 1918 address spaces available to us. We say /24 to indicate what the subnet mask is, and we say which device we want. And in this case, it's going to be sharing ETH0, but we're saying :1 to differentiate it from the default ETH0 interface. So it didn't give us any error output, indicating that it probably took it. We can investigate this by showing IP adder show. Now, unlike the previous example, we show our new interface added here. Now, it doesn't mean, just because we added this IP address, it doesn't mean it will instantly be able to communicate on the network. The rest of the network must understand also how to route this IP address and how to access it. If the network isn't configured for the 192.168 address space, it won't do anything. But now we know how to configure it on the host itself. We can later remove that address if we wanted to by just replacing add with del. And if we investigate our output again, we see that second interface has been removed from the system. As Linux system administrators, we often need to configure routing properly for our box so that the Linux system knows how to access different networks as needed. In order to view routes, we can use the IP route show command. This shows us that, for instance, in this first line of output, in order to access the 10.0.2.0/24 network, we go from the device ETH0 and we go out this configured IP address. So it's saying use this interface to access that network. Or for instance, in the 192.168.10 network that we configured by manually adding that second device, we also go out the ETH0 interface, but we take the other IP address. So it's just telling the Linux system, in order to access this network, leave via this interface. Importantly, we have a default route. The default route is what the Linux system takes whenever it doesn't have another route to use. So most commonly, when you're out there accessing the internet, you don't want to have to configure every possible network on the internet. It would be impossible. So instead, we set a default. We send all of our traffic to that upstream default gateway, and that's where it will send packets if it doesn't have another configured network to use. The deprecated tool to show the route table is via netstat-rn. So this shows us a lot of the same information as the previous command, only in a different format, via a table instead. So we can see, for instance, our default route here is 0.0.0.0. That's indicating every other network. Go via this IP address, this mask, so this is really telling us every network out there. And this little G indicates that this is our default. So it's a lot of the same information, just displayed in a different format. Again, this command is deprecated, but still present on basically any Linux system that you'll encounter. It just might not be maintained forever. So far we've seen how to view IP addresses and add new IP addresses and configure routing only via the command line, but these wouldn't persist. If the system were rebooted, all of this information might change. The IP address that we statically configured would disappear, and sometimes clearly you want that to persist between reboots. So in order to do that on a CentOS system, this is a detail that varies between Linux distributions, we go to etc sysconfig network-scripts directory. There's a lot of files in here. We can ignore most of them safely, but the important one is this file ifcfg-eth0. So this is the configuration for the eth0 default network adapter. First line is the device name, eth0. The next line says boot protocol, that stands for. And it's saying obtain your IP address automatically via DHCP. So this Linux system doesn't have a static IP address. Many servers, certainly servers in corporate networks, will have static IP addresses configured, in which case you would change DHCP to the word none. We have optionally specified here the hardware address. This is the MAC address of this system. And some additional details. On boot says yes, so this means that you want to bring this interface up at boot time. It's an Ethernet adapter. It shows its UUID. Notice there's no IP address configured here because it's DHCP. If we needed to configure a static IP address in addition to changing boot proto to none, we would specify IP adder in all caps and set the IP address manually. We'll add a second static configuration file so that another interface comes up at boot. So in order to do that, I'll just make a copy of the previous one to save myself some typing. So we'll add the same interface that we added manually earlier, only this time it will persist between reboots. And I'll go ahead and edit that file using my bash shortcut for the last argument on the previous command. Okay, so this time we'll set it up as a static address. So we'll set it to eth0:1 as the device name. I'll set boot proto to none. I'll go ahead and delete these lines because they're optional and I don't need them. And here I'll set the IP address, and I'll set it to what we had configured before, 192.168.10. Actually, I'll set it to 10.11. And I use :WQ and VI to save that. Now I can use the ifup command, which is a command that will read this configuration file and bring my interface up. So sudo ifup eth0:1. It's attempting to bring up the interface. And now it's up. If I look at the output now with IP adder show, I show 10.11/24. I also show 10.10/24, which I had configured previously. But this is showing me that it's a secondary interface. It's also visible in the ifconfig output. We see it here. Shown up as 192.168.10.11. And if I were to reboot my system, which I won't do now, it would also come up automatically at boot. In order to bring it down, I can type ifdown eth0:1. And if I retype ifconfig command, I don't see it in the output anymore. Notice that I didn't bring up or down the eth0. The reason for that is that I'm currently logged into my Vagrant box over that interface via SSH. If I were to bring it down, I would lose my connection and my host would no longer be accessible. This is a common thing you might encounter when you're accessing systems remotely over the network doing normal system administration duties. You want to be very careful not to make changes to interfaces when you're logged in remotely, as you might lose that connection. This configuration file anymore, I'm going to go ahead and delete it. Sudo rm ifcfg-eth0:1. So now we've seen how to add new interfaces, bring interfaces up and down on the network, make sure that interfaces will start at boot time. It can sometimes also be useful to examine current network connections. In fact, this is very often the case for a busy server system. You want to see how many network connections that system has at the moment, what state those connections are in, what other systems on the network your Linux box is talking to, and Linux has built-in tools for that. So one such tool, part of the same suite of tools as the IP command, the IP route suite, this is the SS command. So we can use SS-A to show us all active connections. So there really aren't very many on this not very busy virtual machine of mine. We see in the very first column, we see the state of this connection. We see that this is a listening connection, so there's something listening on this port. And we can come over here and we can see what's listening. It looks like it's on at least the same port that SSH uses, which is 22. So what we see is the state that it's in. We show if anything is queued there. We show what the local address is and its port, and we show what the remote address is and its port. So let's look at the last line. This is an established connection, meaning it's open and in use. It's to the SSH port on the interface 10.02.15, and it's communicating with the peer 10.02.2. That would be my laptop. This is showing the connection from my laptop SSH'd into my virtual machine. So this will show us all of the connections out there. Now, one thing that's interesting is we're not seeing a number here for port. We're seeing the interpretation information. So it shows SSH rather than 22. Sometimes it's useful to actually see what the port is, and we can do that with the N flag. So now we show that rather than SSH or SMTP, we see 22 and 25 in place of that. You'll often want to add the N qualifier when you really need to see what the port number is. This information about what name it should use here is pulled from a file in the system called etc services. So we'll just take a quick peek at etc services. This is a list of registered ports. So we can see, for instance, port 21 is registered to the FTP protocol, port 21/TCP, port 23, which is Telnet, is registered here. This is a little less frequently used these days, but used to be the standard way of accessing systems remotely. And there's really a lot of registered applications in this file. Anytime you see something in the output of SS-A that you're not familiar with, you can consult etc services. What I like to do is say grep for SSH and /etc/services, and it shows me various places here, and you want to look for the exact match. So if I'm searching for SSH, I look for exactly SSH in this output, not SS shell, not SDO-SSH, but actually just SSH. So that gives us the name to port mapping information. We can see the same information using the netstat command, the deprecated tool that will maybe one day be phased out. We can show netstat -an. So netstat shows us not only TCP information, but also UDP information. So we can see here that we're listening on UDP port 68, and it's listening for anybody to connect to it. And we can also see Unix socket ports. So we're not seeing that in the SS output as it's limited to just TCP IP or UDP as well. This might be removed in a future update. We can type sudo netstat, and we'll give it some different flags. The last time we typed -an. And this time we'll add some more qualifiers. We'll add -ANLP. And we'll see what the difference is here. One difference we can see is that we're actually now seeing the program output. We're seeing which service, which running process is using that port. So port 22, we knew it was SSH because we just know that that's a convention, but now we can actually see the process that's running. It shows us the process ID, the PID, and it shows us the name of the program. So finally, we can use the fuser command, and we can explore very much the same information, but in a different way. I can say, in Linux, everything is a file. So even TCP IP sockets are files, and you can explore them with the fuser or the file user command. You can find out what program is using this file, or in our case, a socket. We can use this syntax, and we can see that these PIDs, 1201, 1273 and 1275 are using port 22 TCP, and I could search the process table for that information. So here I can see SSHD is using that port. Here's the process. So that's a quick way to understand what application has a given port open, and that can be really useful. One final thing to investigate, and we've seen this a bit in the earlier examples under processes, under /proc/sys net IPv4, we have a whole host of TCP and IP configurations. This is how the kernel is configured to manage TCP. So an interesting one, for instance, is the IP forward. Currently it's set to 0. So if this Linux system, my virtual machine, received an inbound packet and was asked to forward that on, say it was asked to function as a router, it wouldn't do it because it's configured not to do so. But if I wanted it to, I could change that to a 1. I could say sudo, I like to do it this way, open a subshell with sudo and say echo 1 output to IP forward. And now we can see it's set to a 1. So now this Linux system will act as a router and forward packets to other networks. So that's the real quick and dirty of configuring Linux for TCP IP. We learned how to add and manipulate IP addresses on different interfaces and show what IP addresses are configured. We looked at the route tables with the IP route show command. We also configured static interfaces and learned how to investigate the status with sudo ss-an, for instance, to show us what the current connections look like. This is really a core competency for Linux system administrators, and you should take the time to really understand in depth all of the commands here.